In week 12, we're learning about mountain building and plate tectonics. Today, the lab will be modeling the 5 basic types of mountain formation, the 5 types of mountains. As a review, remember we have 3 plate boundaries, the convergent, the divergent, and the transform. We'll be relating these to 3 stresses: compression stress, tension stress, and shearing stress. The handout that goes with this lab, if you want to follow along at home or do this activity, is posted in week 12 in the information folder in Blackboard. What would you need for this lab? Well, you could use clay, you could use salt clay if you make it at home, or you could use 3 layers of towels or fabric that are different colors. So, the first thing you're going to do is flatten out your clay into layers. You want 3 or more different layers of clay, different colors, and you need 3 or more different setups. And you work with these individually. Okay. You would want to take a picture of your initial setup. The instructions ask you first to apply compression stress. That means you're going to push slowly the layers together until you form a mountain. Notice how the layers have folded and a valley has formed on either side. When you apply compression stress, you would find this along a convergent boundary where 2 plates move together. And you would form a folded mountain. The up folds are called anticlines, and the valleys or down folds are called synclines. Examples of folded mountains would be the Himalayas and the Appalachians. Next, you're asked to apply tension stress. In this case, you're going to pull the layers apart. Eventually, you'll create a fault or a break between the 2 layers, the 2 setups. Okay. This would be along a divergent boundary. The part that is higher, the mountain, is called a horst, and the valleys are called grabens. These are fault block mountains. You would find this type of mountain in the Basin Range area of the southwest of the United States. Okay, so next, the lab asks you to apply shearing stress. This most likely one would find along the transform boundary. So you need to take your layers. One part of your clay will go in one direction laterally, and the other part will go in the other direction. And there may be some twisting as you find shearing. Eventually, the layers would break apart again in a fault. These are areas that are often associated with earthquakes, like along the San Andreas Fault in California. So the types of mountains to review that we formed are the folded mountains, the fault block mountains, and scarps that one would find along a transform boundary. But what about mountains that are not formed along plate boundaries? Not all mountains are. For this, the lab asks you to apply the pressure either from underneath, uplifting the layers, or from above, depressing the layers. So, the first types of mountains you're going to form are warped, and you can either have up warps or down warps. Applying pressure directly underneath your layers. These are a little large there. Okay. You notice what happens, you start to form a dome. Okay, the pressure is uplifting right from underneath. Okay, I'm going to get a dome. Similarly, if there was pressure from above, say a glacier, meteorite, avalanche, landslide, anything from above, you're going to end up with a basin. But what happens in the upwarp situation when the uplifting continues? What type of mountain would be formed? The volcano. Volcanoes can be formed in mountains that are along convergent boundaries, where one plate subducts under the other, melts, causing uplift or upwarping to become a volcano. But in areas where there are magma plumes underneath the middle of a plate, like along the Hawaiian Islands, you get upwarped volcanoes. So there's only one other basic type of mountain, And those are called accreted. Or accretion wedges. In this case, you have a landmass, a continent or island, and if a plate is converging across the oceans, eventually, let's do it this way so you see the color difference. The two will meet and converge, applying compression stress and adding mountain ranges along the coast. Much of California was accreted from across the Pacific Ocean. Similarly, the continent of Asia did not have India attached to it. India, which now is causing folded mountains in the Himalayas, when it first arrived, was an accretion wedge. These pieces that are added on are called terrains. So, to review, the 5 basic mountain types that you should have been able to model in this lab are folded, faulted, or fault block, upwarped, or downwarped, we have our volcanoes and our accreted. With this information, you should be able to complete the analysis and conclusion questions using the data from the lab, your observations, and information from the textbook. If you have any questions, please contact me via email.